All right, section 3.6, types of triangles. There's a few ways to classify triangles. One is by their side lengths. So looking at this first triangle on the left, if we have no two sides that are congruent to each other, this is what we call a scalene triangle. So there you go, scalene triangle, no two sides are congruent. There you go, scalene triangle, no two sides are congruent. All right, looking at the triangle next to it, the triangle in the middle there, notice we have two sides that are congruent. This is what we call an isosceles triangle. You may have heard of this before. And isosceles is spelled kind of funky, I-S-O-S-C-E-L-E-S, an isosceles triangle. At least, keywords there, at least two sides are congruent. There you go, an isosceles triangle, at least two sides are congruent. So as we go to this triangle up top here, up above it, notice that we have two sides that are congruent. We call these the legs. So we have a leg and a leg. The side that is the non-congruent side, we call the base. The angle that adjoins the two legs, so where the two legs meet, which in this triangle is at vertex D, this is called the vertex angle. The vertex angle is there where the two legs meet. And then where the base meets a leg, we have angle E, and where the base meets the other leg, we have angle F. These are called base angles. So angle E and angle F, these are actually congruent to each other, and these are called base angles. So there you go, angle E and angle F, those are what we call base angles, where the base meets the leg, and the base angles are congruent. Let's make a note of that down below in the definition of an isosceles triangle. The base angles are congruent. The base angles are congruent. Okay. The third triangle we have here is a triangle where all three of the sides are congruent. This is what we call an equilateral triangle. So there you go, an equilateral triangle, all sides are congruent. And there's something else special happening in an equilateral triangle as well. All the angles are 60 degrees. So here you see in the figure angle H congruent to angle G, congruent to angle K. All the angles are congruent and they're all 60 degrees. And you see that note right there, all angles are 60 degrees. Okay, so that's classifying angles by their side length. Scalene, no two sides are congruent. Isosceles, at least two sides are congruent. And equilateral triangles, all sides are congruent. So with an isosceles triangle, at least two sides are congruent. Equilateral triangles are also isosceles, right? So let's make a note of that. All equilateral triangles are isosceles. There you go. So all equilateral triangles are isosceles. Not all isosceles triangles are equilateral. So this triangle in the middle is an example of a triangle that is isosceles, but not equilateral. But remember, if at least two sides are congruent, when all three sides are congruent, that is at least two, right? So all equilateral triangles are isosceles. Not all isosceles triangles are equilateral. All right, we can also classify by their angle measures. And by the way, the reason I'm pausing the video, my OneNote's been jumping around a ton. I've really just been having a hard time with OneNote over the last 3 or 4 days. So thanks for hanging with me with the pausing and all that stuff. But that's the reason I'm doing that. Classifying triangles by their angle measures. This triangle on the left here, let's put some angle measures to it. Let's say it's 60, 40, and 80. So something like that. 60 degrees for angle B, 80 degrees for angle A, and 40 degrees for angle C. I don't think we've covered this yet, but if you add up all the angles of any triangle, it has to be 180, right? So think back to the equilateral triangle, 60, 60, and 60. That's 180. Right here, 60 plus 40 is 100. 100 plus 80 is 180. It's always going to be 180 degrees. This is what we call an acute triangle. Why is it an acute triangle? All three of the angle measures are acute angles. So there you go. An acute triangle is a triangle in which all angles are acute. All of them. Not just two, not just one, all of them. All right. On the right here we have angle E is a right angle. This is what we call a right triangle. So in this triangle we have one right angle. If one angle is a right angle, this is what we call a right triangle, a right triangle. Now with a right triangle, the side opposite the right angle, the side opposite, I'll pause, let you write that down. Or maybe you can pause the video, that might be better. The side opposite the 90-degree angle is what we call the hypotenuse. Let's see who's jumping. All right. Hypotenuse is the side opposite the 90-degree angle. What do you mean by opposite? Well, notice angle E. Angle E is formed by sides DE and side FE. So it's the side that does not intersect with our right angle. So that's side FD. The two sides that do intersect with our right angle, or the two sides that form our right angle, are called legs. There you go. So DE would be a leg here and FE would be a leg. So notice the difference between the legs in a right triangle and the legs in a isosceles triangle. In an isosceles triangle, the legs are congruent. That's not necessarily the case in a right triangle. So in this triangle, if it's drawn to scale, you can clearly see that FE has to be longer than DE. Assuming it is drawn to scale, we cannot assume that unless you're told it is drawn to scale. But yeah, in an isosceles triangle, the legs have to be congruent. In a right triangle, the legs don't have to be congruent. Remember, in every triangle, the sum of the angle measures has to be, do you remember? 180. So if angle E is 90 degrees, how many angles remain for the other two angles? So for angle D and angle F, how many degrees remain? 90 degrees. What is it called when two angles have a sum of 90 degrees? It's called complementary. So let's make a note of that. Angle F and angle D are complementary. So let's put some angle measures to this. If angle F is, let's call it 35 degrees. If angle F is 35 degrees, what would angle D have to be? It would have to be 55 degrees. There you go. Now, what's 35 plus 55? It is 90. What is 90 plus 90? 180 degrees, which takes us to the triangle sum theorem. So over here on the left, let's write this. Triangle sum theorem states that the sum of all three angles of a triangle is 180 degrees. There you go. Triangle sum theorem. The sum of all three angles of a triangle is 180 degrees. Triangle sum theorem. Okay. We have a couple more types of angles or types of triangles we want to look at that are classified based off their angle measures. Here, assuming this is drawn to scale, angle H is going to be an obtuse angle. Let's give some angle measures to it though. Let's say angle H is 120 degrees. No, I meant to say 110 degrees, excuse me. So let's call it 110 degrees for angle H. Angle K, let's call that 30 degrees. And angle G, let's call that 40 degrees. All right, so notice we have one angle that is obtuse. That's all you need for a triangle to be classified as an obtuse triangle. In fact, remember the triangle sum theorem, when you add up all the angle measures, it has to be exactly 180. Well, what's 90 plus 90? If you had two right angles, 90 plus 90 is 180. You have no degrees left over to give to the third angle. So it is impossible to have two angles at 90 or larger. You can have one at 90 or larger, but you can't have two at 90 or larger. So you can only have one obtuse angle in a triangle. So this would be classified as an obtuse triangle. What is an obtuse triangle? An obtuse triangle is a triangle in which one of the angles is obtuse. There you go. A triangle in which one of the angles is obtuse. Pause the video and write that if you need to. Over here on the right, we have an angle in which all three of the angles are congruent. So angle A, angle B, angle K, they're all congruent to each other. If we're going to classify this by its angles, we're going to call it equiangular. Equiangular. Equiangular, all angles are congruent. Now, in every equilateral triangle, we said all three of the angles must be 60 degrees each. which means every equilateral triangle is also equiangular. And it goes the other way as well. Every equiangular triangle is also equilateral. So it goes both ways. I think I said that right. Every equilateral triangle is equiangular. Every equiangular triangle is equilateral. So in triangles only, equilateral triangles are equiangular and equiangular triangles are equilateral. Think about quadrilaterals for a moment. Can you think about two quadrilaterals that are equiangular, but they are not equilateral? Two quadrilaterals that their angles are equal, but their sides are not. I want you to picture a rectangle and picture a square. All four angles of both are 90 degrees, but in the rectangle, all four sides are not necessarily congruent. How about two quadrilaterals that are equiangular? No, wait, we already did that one. That are equilateral. Two quadrilaterals that are equilateral, but are not equiangular. Do you know what a rhombus is? A rhombus is a four-sided figure, kind of shaped like a diamond, they call it sometimes. Shaped like a diamond, where all four sides are congruent. Those are so in a square, all four sides are congruent as well. So a square and a rhombus, all four sides are congruent, but not all four of the angles are congruent. So rhombus and a square, equilateral but not equiangular. But that's true in other polygons as well. So pentagons, hexagons, whatever. Only in triangles do we have equilateral figures that are also equiangular all the time. Example 1, I think you can do this one. Pause the video on your own and work example 1. Okay, let's take a look at it. If the perimeter of triangle SKY is 80, determine whether triangle SKY is scalene, isosceles, or equilateral. Well, if the perimeter is 80, how do we find the perimeter? We add up the side lengths of all three of the sides. Notice I have an x in SK, I have an x in SY, I have an x in KY. So I just need one equation to solve for x. Once I solve for x, I can substitute in the value of x and find the different side lengths, which will allow me to determine if this triangle is scalene, isosceles, or equilateral. So let's set up our equation. There it is, 2x plus 13 plus 5x minus 8 plus 3x plus 5. That is equal to 80. Let's combine like terms and solve. I get 10x plus 10 equals 80. 10x equals 70. Divide by 10, and x has to equal 7. So now let's find the side lengths. SK is equal to 2 times, instead of x, you sub in a 7 plus 13. That's going to be 14 plus 13. SK is 27. For SY, 3 multiplied by, instead of x, you plug in a 7. That's going to be 21. 21 plus 5, we get 26 for SY. And for KY, 5 multiplied by, instead of x, you sub in a 7. That's going to give you 35. 35 minus 8, we get 27. So 27 for KY. And we're able to determine that triangle SKY is isosceles. Now, just a quick word, if it were to come out to be equilateral, do we need to state that it is both equilateral and isosceles? Because remember, every equilateral triangle is isosceles, and it just depends how the question is worded, right? So if you told me it's equilateral and isosceles, if it were equilateral, right, which it wasn't here, but if it was, I would take that every time. If the question reads, does not specify anything, it just says clarify it, or like for example in this one, if it says scalene, isosceles, or equilateral, and you just said equilateral, that would be fine. So I would take equilateral and isosceles together, right? That I would take that all the time. I would also take just equilateral. But if the problem says classify the triangle like by all its names or something like that, like by all the possible classifications, if it is telling you to give every classification that describes that triangle, in that situation, you'd have to give me equilateral and isosceles, okay? So just be careful of the wording. No wording like on this one, I would take just equilateral. That'd be fine. But I would also take equilateral and isosceles, so whatever you want to do. But you do need to know that every equilateral triangle is isosceles. That didn't come into play here, but it might come into play later. All right, on to example 2. I would encourage you to do what you can on your own. These proofs, it's good for you to practice on your own as much as you possibly can. So here we go, example 2. Okay, so CA, let's find CA. CA is right here, is an altitude of triangle CRT. What does that mean for that to be an altitude? It means we have a 90-degree angle here. Not only do we have a 90-degree angle CAT, we have a 90-degree angle CAR. And remember, all right angles are congruent, so these two angles are congruent to each other. I also am told that CA bisects angle TCR. Okay, well here's CA again. TCR has been bisected, which means RCA is congruent to TCA. We have two triangles. We have a triangle on the left and a triangle on the right. Both these triangles share CA as a side. So what do I know about these two triangles, the one on the left and the one on the right? They have to be congruent to each other. Through what congruency postulate? Angle, side, angle. What are we trying to prove? We're trying to prove that triangle CRT, that's the biggest triangle here, CRT, is isosceles. If this triangle is isosceles, then at least two sides are congruent. Well, if the triangle on the left and the triangle on the right are congruent to each other, we're able to use CPCTC to show that CR is congruent to CT. So again, take the given information to show the pairs of angles that are congruent, use the reflexive property to show CA is congruent to CA, and then CPCTC to show that CR is congruent to CT. If you want to pause the video now and try the proof on your own, go ahead. Otherwise, I'm just going to be working through it rather quickly. First off, CA is an altitude of triangle CRT. That is given. Number 2, what does it tell us if CA is an altitude? It means that angle CAT and angle CAR are right angles. So you can either couple these together into the same statement, or you can uncouple them and have them be in two separate statements. Either way is okay. So angle CAR and angle CAT are right angles. How did we know that? Well, that's the definition of an altitude. There you go, definition of altitude. All right, well, if CAR and CAT are both right angles, what do we know about them? Again, we're trying to prove the two triangles are congruent. If the two triangles are congruent, we have to have congruent angles and congruent sides. So angle CAR is congruent to angle CAT. How do we know that? All right angles are congruent. There you go. All right angles are congruent. All right, so we've got one pair of congruent angles. Let's go back to our given information. CA bisects angle TCR. How do we know that CA bisects angle TCR? That is given. And what does that tell us if CA bisects angle TCR? Remember, we're trying to prove that pairs of angles and pairs of sides are congruent so that we can prove these two triangles are congruent, triangle CAR and triangle CAT. Well, we know that angle RAC here on the left is congruent to angle RAC on the left, back up, I'm saying that wrong. Angle RCA on the left is congruent to angle TCA on the right. There you see that. Angle RCA, double check it, RCA is congruent to angle TCA. How did we know that? It's the definition of bisect. All right, we're getting there. Remember, we want to prove these two triangles are congruent, so we're also going to show that CA is congruent to CA. How do we know that CA is congruent to itself? That is the reflexive property. There we go. And now we know these two triangles must be congruent. Be careful with your congruency statement. Triangle CAR, that is the triangle on the left, is congruent to triangle CAT. I checked my congruency statement. Corresponding parts are in corresponding positions. The angle at vertex C in CAR and the angle at vertex C in CAT, they are congruent. The angle at vertex A in CAR and the angle at vertex A in CAT, they are congruent. Same thing with the angle at vertex R and vertex T, even though we haven't proven that yet, but they are congruent. How do we know that those two are congruent? Angle, side angle. There you go, angle, side angle, congruency postulate. Okay, remember, we're trying to prove that CRT is an isosceles triangle. We said if we can show that CR is congruent to CT, which we now can show, we know that CRT must be isosceles. And there you see that. Side CR is congruent to side CT. How did we know that? corresponding parts of congruent triangles are congruent. CPCTC. And then finally, we know the triangle CRT is isosceles. And how do we know it was isosceles? This is a new one. See if you can figure it out. Definition of isosceles or isosceles triangle. There you go. There is a completed proof for example 2. Yeah, these proofs are hard. You're getting better at them. Stick with them. Remember, we see difficult ones in the homework. We see difficult ones in the notes. The ones in the test are still difficult, but they're not like the super high level stuff that we see in the homework and the notes a lot of times. So just stick with it, and keep in mind too, you're probably not going to miss all 9 of these steps in a quiz or a test. So like, please don't feel uh, overly anxious or overly stressed out regarding proofs. You are growing and improving every single day, and hopefully you're understanding this, but maybe you're not understanding it by yourself, but as we go through it, I hope you are understanding it. But just know in time you will get better at this, and you won't feel anxious about it or anything like that if you do right now. All right, take care. Have a great day. Bye.